Continuing on with this postulate, the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So all this is saying is that if we look at arc ABC, so A, B, C, and if we knew the measure of arc AB, we could just add it. If we knew the measure of arc BC, we could add the two together and that would give us the complete measurement of the arc. So if, like I said, that this arc was 120 degrees and this arc was 120 degrees, so if I knew from A to B was 120 and from B to C was 120, then I would know that from A to C, well, that would just be 120 plus the other 120, which would give me 240. So find the measure of every possible arc in circle P. Okay, so just naming the circle using the center point P, I know that from R to P to S, or angle RPS, is 110 degrees. So go ahead and tell me then, what are the other angles measurements in this circle? So what is the measurement of angle TPS? What is the measurement of angle TPR? And then how does that help you figure out the measures of the arcs? So looking at this problem, since we are going from the central point P, and if I know that this central point, then that 110 has to be the central angle, so then that go ahead and that tells me that arc RS has to also equal 110 degrees. And then I have this line. I know this is the diameter line because that line or that chord goes through the point P. So since it's my diameter line, I have a straight line. If I know that this degree here is 110 degrees, I also know that lines are 180 degrees, so that tells me that this last section here has to be worth 70 degrees. So that means arc TS, or ST, has to be 70 degrees. And then lastly, we know a circle has to equal 180 degrees. So if I have, 360 degrees. So if I have 110 and then I solve that this was 70, I know that the remainder of the circle has to be 180 degrees. So that means arc TR, or RT, has to be equal to 180 degrees. The circle graph shows data collected by the U.S. Census Bureau on the highest completed education level for people 25 and older. Use the graph to find each of the following arc and angle measures. Round to the nearest tenth if necessary. So go ahead and looking at this chart, we're given some categories and some percentages. Now, remember, we already talked about the fact that a circle is 360 degrees. So since we have each piece of this circle given to us in percentages, what do you think we have to do? So one way that you could go about solving this is taking that percentage of 360 degrees of that section is going to give you the arc length. So CAB, 32% of 360 is about 115.2. EAC, if I look at that E to A to C, I'm going to take these two percentages, 18 and 17, add them together, and that gives me 35. 35% of 360 is 126. GF, that represents the 1%. 1% of 360 is 3.6. Measurement DAG. DAG is a central angle, and then I'm just going to go ahead and take those pieces that it takes to get from D to A to G, which is the 1, the 7, and the 18%, and that gives me 26%, and 26% of 360 is about 93.6. And then arc BG, so going from B to G, that's 25% of our circle, which is 90 degrees. And then arc BDE. Okay, so B to D to E. So I'm looking at 1, 2, 3 sections of my circle. If I add those 3 sections up and then take that percentage and multiply it by 360, I get 241.2 degrees. So then that is my measurements of the arc. And notice for arc BG, I say 90 because if I didn't specify any of these letters in between, you always just want to take then the shortest route. So the shortest route from B to G is that 25%.